Hello everyone and welcome in this new video. This one will be a bit special. I want to introduce a project called Metascore. The video will be divided in two parts. So the first part will be about explaining the project and how people can participate and play with Metascore. And the second part will be for developers. I will explain in details how you can integrate your game with our current implementation of Metascore. And I will guide you through the code as well. Okay, so first, what is Metascore? So Metascore is built to create a leaderboard for all the games of the next Discover hackathon. So we are a community project. If you wanna come and give some help, you can join our Telegram or you can follow us on Twitter. So everything started with Discover Hackathon Season 2. So if you don't know, there is a competition going on Discover, and this one is the second one. And so the goal of this Season 2 was to create what they call integrated game, which means game that can communicate with other applications or other games on the internet computer, or maybe other NFTs on the internet computer. So that was the goal of this season. And by the way, I strongly advise you to participate because first, those competitions are amazing, and secondly, the prize pool for this one is quite huge. Yeah, and so that was the goal for this season. And the project that I want to present will focus on a core aspect of many game, which is score. So as I've said, there is a huge prize pool for developers and people that create games and applications for the next Discover Hackathon. But what about the players? I think the players also bring a lot of value. And so that's where Metascore comes in. So the goal of Metascore is to create a mega leaderboard, and this mega leaderboard will aggregate all the score from all the games of the next hackathon, at least all the games that want to integrate with Metascore. And depending on the numbers of games you've played or the ranking in each of those games, you will get a Metascore score that will be printed on the leaderboard, and you will have a ranking. So that will be a competition between all the players of the next Discover Hackathon. And what is really exciting is that depending on your ranking and what you've done during the tournament, you will get some special rewards. So we have two kinds of rewards. The first one comes from our sponsors, and we have big names from the internet computer ecosystem. We have Tonix Lab, we have Visions, we have Motoko School, we have IC Puppies, Chronix, Starverse, IC Mojis, and IC Puzzle. I really want to thank all those people and all those sponsors because they bring a lot of value here. We have some discussions going on with other potential sponsors, and if you want to be part of the sponsors, just send me a message on Twitter or contact the Metascore account on Twitter as well. So that's the first kind of NFTs we will airdrop to the best players. But we also have a new kind of NFT that I'm really excited about, and those are non-transferable NFTs. So those NFTs will not be sellable, but they will not be buyable by anyone as well. And so they will be granted to the best players of this tournament. And we are still working on what kind of privilege they will grant to those players. But we want to make sure that the first supporters and the best players get a really good reward. So one example of that would be some power on the next tournament. So for example, for the next, for season 3, that would be great to have the best players of the previous season decide the rules for the next season. That's the kind of feature we want to integrate with those non-transferable NFTs. And I'm really excited about that. Okay, so that's it for the Metascore. If you want to know more, I will write an article about Metascore in the next few days. And if you are a developer and you want to integrate your game with Metascore, the rest of the video is for you. I will show you an example of how you can integrate your game with Metascore. Step number 1, you need to install Vessel because you need to import some code from our Metascore repository. As you see, you need to import Metascore from the Metascore repo, and you need to import Player from the Metascore repo. Vessel is a package manager for Motoko. If you don't have Vessel installed, you can just import modules from the base Motoko library. You are probably familiar with that. You can import array, hashmap, NAT, those kinds of modules, but you can't import from external repo. That's why we need to install Vessel. And I will guide you through the process of installing Vessel and configuring Vessel. The step number 2 is to use either Stoic or Plug to identify your players. So here's the public type player. A player is either a Stoic or a Plug with a principal. And currently we don't support internet identity because for each application, the internet identity principal is different. So that would be very complicated for us to track players across different games, but we may implement that in the future. For the step number 3, you just need to create an array and stores all of your score inside that array. A score is just a player associated with a value of type NAT. The variable scores should be a stable variable because we don't want to lose the scores if you update your canister. Also, you are responsible for keeping the scores updated because the Metascore canister will periodically check the array and update the leaderboard accordingly. Okay, the step number 4 is a bit more complicated, but I will guide you through every step. You need to implement the game interface, which is the minimum interface we expect for all games to be compatible with Metascore. In reality, it just means that we need to have two functions that you see on the screen. So the functions are Metascore scores and Metascore register self as public functions inside of your code. You can have other public functions, it's not a problem. Metascore scores is a function that will be called periodically by the Metascore canister to check your array of scores, so the array we discussed previously, and update the leaderboard if needed. Metascore register self is also a function that will be called by the Metascore canister, but this time it will be called when you try to register, and basically your canister will answer this call with some metadata, so for instance, the name of your game. That's it for the basic steps, so let's dive into the code. Okay, let me show you how to install Vessel and configure it. First, you need to go to this repo. I will provide the link in the description, the definity/Vessel repo. And then you need to go here and download the Vessel binary. I am on macOS. The process should be similar on other platforms. Okay, so it has been downloaded. Now you need to go to your terminal, and I will move to my downloads folder. And here I will open it, and I should see the Vessel macOS. It's here. If you don't see, I'm going to zoom a bit. That's the Vessel macOS. But you can see that it's not executable. At least the macOS system doesn't recognize him. So you need to make it a binary executable. And for that, we need to run a command. So sudo chmod +x and then Vessel/macOS. And now it's executable, so we can execute it. So we can check Vessel-macOS. And it's not found because it's not in our path. So what we need to do is go to the right folder, and we need to add this executable to our path. So for that, so I'm on macOS again, so it should be different on other systems, but you can check on the internet. And here I need to go to user. So user, then I think it's local, and then sorry, it's in binary. Yeah, so I want to correct. Then I can open this folder, and as you can see, I have some binaries and I have already Vessel, so I'm not going to move it, but you should move it and maybe rename it to Vessel. It will be easier to execute later in the future. Okay, so now we just want to check that everything was successfully installed. And for that, just run the command Vessel. And you should have a pretty simple message saying that Vessel is version whatever version and is a package management for Motoko. So if you have this message, it means everything was correctly installed. Okay, now you can run the command Vessel init. And this command will create two files. So the first one is Vessel, and the second one is package.set. And what you need to do now is just go to the MetaQuiz repo and copy the two files from this repo. So copy the Vessel like that, put it here, and copy the package set as well. Okay, so that's it. That should be pretty fine. Now you can go to the defx.json, so the configuration file, and in default build and pack tool, you need to specify that you are using Vessel, and for that, just write Vessel sources. Okay, so now it means that inside the Motoko file, so the main.mo, I can import from the base library. So I can import option, I can import iter, array, nat, hash, everything. So if you are familiar with Motoko, that should be pretty familiar for you as well. But I can also import from the Metascore repository, and I needed to import Metascore and player from this repo, and that's why we imported that's why we installed Vessel. Okay, so step number 2 is to connect your players with their Stoic or their plug identity. I'm not going to dive too much into this step because there is already a lot of documentation on the plug website or on the Stoic identity repo. I will provide the links in the description, but I will quickly show you what I've done, and if you have more questions, there is always the repo if you want to check. So basically my logic is that I have two components, so I have the plug one and the Stoic, because I wanted to separate the logic. And when my user chooses either Stoic or either plug, it will show one of the two components. So here we are inside the plug component, and the main function is the register function, which is called when the user registers, indeed. And so inside this function, I'm creating an actor. So I've called it my game actor. And basically, an actor is the JavaScript representation of your canister. So this is my representation of my game canister. And this function is being called, so the actor class is being imported from the Definity agent package, which is an npm package that you need to have inside your package.json. So I import actor. And inside, I have the ideal factory, the canister ID, the windows.ic.plug agent. So ideal factory, I'm not going to explain too much, but basically this is what creates the interface of the canister. And it's being imported from the declaration folder, like that. It's the metaquiz.day.js file. And then, so the canister ID, I think is pretty straightforward. But what is interesting is the agent. So if I did not specify any agent, the method actor.create actor would work. But in that case, I would make anonymized call to my canister. And I don't want that. I want to register a player, and I want to keep track of its identity. So I'm using an agent, and this agent is using the plug agent, windows.ic.plug agent. So in the case of the user having the plug extension, of course. And so what this does is that when my user will call my Motoko function, so here, sorry, let me find the function. It's add player. Yeah, this one. So I can use the message.caller on the message, and it will print the principal of my user. That's why I needed to incorporate the agent here. And so then I have my actor. I just check if we are not in development. If you are in development, you need to fetch the root key. Then I create my object registration, which is composed of a player and its name. And here I specify that it's a plug player. So be careful, because the variant types in Motoko and in JavaScript have not the same syntax. So you need to check on the Definity website. But you can also check on my example. And then I just add my player with the add player function, and I pass the registration object. And inside my Motoko code, so I check if the person that is being registered is the person that is calling, and that's why I needed the agent. And then I just check if the user already exists, and if it doesn't already exist, I just add it to the players list. So that's it for the identity logic. I don't think I need to dive more into that. You can check the repo if you want. If you have any problem, just hit me on Twitter or on Telegram. Okay, so let's go for the step number 3, which is to implement the game interface. So I've already done it in the main.mo file. which is what you will be able to see on the repo. So here I have implemented the game interface. But for the sake of the video, I'm going to do it again and guide you through the process. So I've created a new Motoko file, example.mo, and the first thing we need to do, is to import Metascore and import player. So like that. Okay, the second thing we need to do is to implement and create our actor. And for that, we are going to copy and paste this part. So let me explain what everything means. So we are creating an actor, and the class of this actor is MetaGame, and the class MetaGame is of type metascore.gameinterface. It's async because when you create the actor, there is a little delay. And shared means that this actor is a shared actor. You can create it from wherever you want. And the person that calls the actor the first time, so the person that creates the actor for the first time, is called the owner. So you can reference it into your code later. And also the self keyword is used to reference that actor. So it's the name of this actor. And you can use the self keyword inside your code to talk about your actor or reference it if you want to. Okay, so we have our actor. Now we need to write the internal code of this actor. So, okay, let's start with creating the Metascore actor and interact with it. So this line of code will create an actor, and it will allow us to interact with the Metascore actor, which is with the Metascore canister, which is living on the internet computer. So we just need to specify that it's an actor, and we need to specify the right principal ID. I don't think the principal ID will change, but if it's changed, I will specify it in the description. Okay, and now we need to copy and paste the public type player because we want to implement our players like that. And then we need to have some helpers function. So just copy and paste all those functions. Those are internal functions. Okay, so that's it for the helpers function. Now we need to have the register function. So just copy again this function. And this register function will be used by you to register your canister. So what this does is that you have so when you call the register function on your canister, it will call the Metascore canister, so the one we have here, and it will call the register function with your principal, so the principal of this canister. And so let me show you. We have the register function here. So this is the register function of the Metascore canister. And once this function is called, it will again call another function on your game, which is called Metascore register self. So we need to have the register function, and we need to have the Metascore register self. And that's inside, so sorry, let me copy and paste this function. So you need to have those two functions. And this function is very important because it will bring the metadata to the Metascore canister. So that's how the Metascore canister knows that the name of this game is Motoko School Quiz 2. And actually, we may want to change that. So maybe this is example for YouTube. Okay, so we have the registers function. And now we need to have some scores. So let me copy and paste that. Okay, so we have this variable, we have this type score, which is a player and a value nat. Don't worry about the value. The Metascore canister normalize all the value for the games. So even if a game, for example, the best score in a game is 100 and the best score in another game is 10 millions, it won't matter because the Metascore canister will normalize everything. So you just need to have those scores, and then you need to store all the scores inside an array. And this array is empty for us, but we will maybe put some scores inside later. So we have our scores, and now we need to implement the last function to respect the metagame, the game interface, sorry. And this last function is Sorry, let me check this one. Yeah, it's this one just here. So this is a required function to integrate with Metascore, and what this does is that it's just query the scores. So that's pretty basic. The last function that I want to show you is, it's not a required function, but I think it's really important that you have it. It's this function, new score. And basically what it does is that it appends a new score to the score array. So like that, it creates a new score and it appends it to the score array. And then it called a function on Metascore, which is called score update. And what this function does is that it will ensure that your game is up to date with our canister. But this function is not ready for the moment, so you can just comment that, and maybe you will comment it later when this function is ready. Okay, so I've made some modification to our actor. Basically, I've imported some modules that were missing, and I also added some scores to the score array. So a plug one with a score of 1000 and a Stoic one with a score of 10. And also I've added the example.mo to the DFX file, and I've defined this YouTube canister. So let's deploy everything on the internet computer. Okay, so everything has been deployed. We can see that the canister YouTube is on the internet computer, and here's the ID of this canister. And now I can call this function, and I can call this canister, sorry, and I can call the function register on the YouTube actor. So let's do that. So the register function is a bit long. You need to wait, I would say 10 seconds. So don't worry if that's the case for you. And we are going to see the answer from the Metascore canister. And here we have successfully registered to the Metascore canister. And if we are curious, we can go and see on the Metascore interface. So the interface is in its early days for the moment, but we can check and see that we have the example for YouTube that has been registered, and we have the two scores. So that was the plug identity, and that was the Stoic principal